Hello and welcome to Unit 4 Practice Problems Part 2. In this video we're going over the first derivative test and the second derivative test. And so the first question asks for increasing and decreasing on this function right here. And for the first derivative test we need to find basically the critical points or the places where the function is changing from increasing to decreasing. So if this was our graph, then right here and right here would be where it changes from an increase to a decrease. And that's also called a max or a decrease to an increase, which is a min. And so to find these, we would have to set the derivative equal to 0. Because when the derivative is equal to 0, that means the slope would be 0, and it would be 0 at these points right here. So to do that, we need to find the derivative. 3x squared minus 22x plus 39. Set it equal to 0 and factor. So we get these points right here, and we can prove that, or we can see that they are the critical points. And now we need to find our intervals that we will be using for the increasing and decreasing. So these intervals would be set up like this. We know that we need to do it in numerical order. And 13 over 3 is about 4. It's actually a little more than 4 because 12 over 3 is 4. So do that and then say that this is greater than 4. And for our intervals, we would have 3, 13 over 3, negative infinity, 3, 13 over 3, and infinity. And now we need to plug these values into our derivative graph, because if the derivative is positive, that means that the slope is positive, and therefore that part of the graph is increasing. And so to find the intervals, over here we would have 4, because it's not exact, the 13 over 3 is not exactly 4, so we can still use 4 as a point. Over here, we can use 0. And over here, we can use, 10. And so we don't actually need to know what the exact values are. We just need to know if they're positive or negative. So if we go back and use this right here, because it's in factored form, we have x minus 3 and 3x minus 13. And we plug in 0 to this from here. Then we would get a negative number because 0 minus 3 is negative 3. And then 0 minus 13 is also a negative number. 2 negatives multiplied is a positive number. For the second one, we would have positive because 4 minus 3 is 1. And for the next one, we would have a negative number because 12 minus 13 is negative 1. So that would be negative. And then lastly, you would have positive and positive to make that a positive. So we can prove that there's increasing and decreasing increasing at these intervals and decreasing at this interval. So increasing at negative infinity to 3 and 13 over 3 to infinity, because the first derivative of x is greater than 0. We can say decreasing 13 over 3 because the derivative is less than 0, or decreasing. So this would be our answer. For our next question, we have find the relative extrema of the function, and then it gives us this function right here. And so to do this, using the second derivative test, we would have to again find the critical points or critical values and then plug that into the second derivative. And if the second derivative comes out positive, then we know it's concave up and there's a minimum. And if it comes out negative, then we can say it's concave down and there's a maximum. Of course, we could still use the first derivative to find out if it's minimum or maximum, or use EVT, but this is just another way to do it. So we have the derivative of y equals 3x squared minus 18x plus 24. We can factor that. And then that would be our critical points. And now we need to plug it into the second derivative. So first find the second derivative, again using chain rule. And then if the second derivative of, say, 4 equals 24 minus 18, which is a positive number. So we don't need to know what the actual value is. We just need to know if it's positive or negative. So that means that it is a minimum because second derivative of x is greater than 0. Or we could write it out as relative min at x equals 4 because second derivative is greater than 0. For the next one, we would have 2 equals, and then we'd have 12 minus 18 equals negative. So it's a maximum because the second derivative is less than 0. And the reason why it's like opposite, you would think that if it's positive that there would be a maximum, but because there's a minimum is because when it's positive, it's concaving upward, and when it concaves up, it automatically creates a minimum. So we can also say relative max at x equals 2 because second derivative is greater than, is less than 0. And those are our relative mins and max. So thank you for watching.